about what ZYY would be without us necessarily having to work through the whole thing. Because ZYY is of the same form, but where there was X, there's Y, but I'm taking the derivative with respect to Y. So, like, when I'm taking the derivative of the inside of this, it should be 2y and not 2x. So, like, this would be 2y, this would be a y. So,
It all works out the same way.
I know, it should all work out the same way, so we should end up with minus y squared, but we'll double check it. Okay, this is my initial instincts, okay, but I will step back and think about it in a minute. Okay, I think ZYY should be that because I would have denominator, and then when I'm taking the derivative of the numerator, I would have y times derivative of this would give me, but when I finally took the derivative of the inside of this, I would have 2y instead of 2x, and then I would have second times derivative of this would still be a 1. So then that's denominator times derivative of the numerator minus the numerator, so that would be y cosine times the derivative of the denominator is going to be the same thing, but with a y where the x was. So that should make this y squared and this a y squared. Should cancel out, leaving me with an x squared, because the 2y squares would have canceled out. So I don't think that is the case. All right, so if we multiply both of them together.
Yeah, why?
I'm sorry, what?
Josh was asking about something. What was that?
It was not related,
Okay,
sorry.
right. Okay, if we multiply ZXX with ZYY, let's just kind of step back and look at what would happen if we multiplied both of them together. Yeah, well, let's just kind of block it out and see what we end up with. So again, we're looking basically for whether D is positive or negative. That's what we're looking for.
D is basically Z, right?
D is basically Z, no? It's F double X times F double Y minus FXY squared.
Oh, so that's like the formula for D?
It's in your notes.
Oh, yeah.
Okay, so ZXX times ZYY, if we multiply these two together, we know that the denominator is just going to end up being x squared plus y squared to the 9/4 power. Wait, we'll add 3, no, hang on. I'll add the powers, so 1/2 plus 1 would be 3. If I multiply those two denominators, I'm going to add my powers together, and 3/2 plus 3/2 is 3. So then, foiling out the numerators, I would have x squared times y squared times x squared plus y squared times sine squared. Okay, so that's first times first, and then my outer terms multiplied together is going to give me minus y to the 4th inner is gonna give me minus x to the fourth, basically the same thing. And then the two outers give me x squared times y squared times cosine squared. So we're gonna have to be done with this line.
Wait,
I foiled out the top, is what I did. So,
right,
oh, I think this will be to the first power. Thank you. No, that won't. Sorry, I wish it was easier for me to see from here to there. The outer row, and then the inner.
Thanks a lot, buddy. Yeah, those are useful, it's not.
Yeah, I think it's foiled out correctly. Notice that I've got the sine squared times a cosine squared, but they're being multiplied by different things, so I can't factor them out nicely. But, you know, what's interesting is that at our point,
you can take, you get your minus y to the fourth and your minus x to the fourth are multiplied by the same big thing, so you could just write the big thing once and
yeah,
have the
we
minus
could,
y,
we
minus
could do
x.
that. But, you know what I'm